Okay, here we are finally factoring trinomials, and it's the final method. We've assumed that it is not a perfect square. The leading coefficient is not 1, so therefore we're going to use this factoring method called the AC method, or sometimes called expanding the middle term, and you'll see why it's called both of those in just a second. So maybe you have seen by now that factoring is just like the distributive property and foiling going backwards. So that's what we're going to do here. We're going to examine this as an example, 2x plus 3 times x plus 4. We're going to FOIL it out and see if we can see some sort of pattern that'll let us know how to factor that. Okay? So whenever I go to FOIL this thing out, the middle term, it would add up to 11x, right? I'd have 8x plus 3x, that would add up to 11x. But right now I don't want to think about that, okay, other than the fact that, hey, yeah, those would add up to 11x. That's 11x. If I expand that out, I'd get 8x plus 3x. Specifically, I want you to look at the numbers 8 and 3, okay? 8 and 3 is what we're concentrating on. Now, if I were to multiply the first term, that's the A, and the last term, that's the C. We're thinking of our quadratic trinomial looking like this. Ax squared plus bx plus c. A is the number in front of the x squared, and the c is the constant term that's right there. If we multiply those together, I get 24. Well, hey, 24 is the same thing that we would get if we would multiply the 8 times the 3, the two numbers from the expansion of the middle term. Okay? And if I were to add those numbers 8 and 3 together, I get the middle term of 11. Okay, and this is going to be the essence of the AC method. It's called AC method because to get the product you have to multiply the A term times the C term. It's also called expanding the middle term because this BX term, you have to expand it out into two little factors, like in this case 8x plus 3x. Alright, so let's look at this going backwards then. I would have this trinomial. I can see that its leading coefficient is a 2. That's not a perfect square. It's not 1, so I'm going to use this AC method. So I'm going to multiply these two things together, 2 times 12, and I have a product of 24. Okay, and then I look at the middle term, and it's going to sum up to 11. So I'm looking for two things that multiply up to 24 and are going to add up to 11. That's going to be my 8 and my 3. So unlike the previous method, I do not put 8 and 3 inside the parentheses. I'm going to use it to expand out the middle term of 11x. I'm going to go 8x plus 3x. Now I'm going, how many terms do you have there? 1, 2, 3, 4. I have 4 terms. I'm going to factor this one by grouping. Okay, so I'm going to put parentheses around the first set. I'm going to put parentheses around the second set. The first set should have a GCF. It has a GCF of 2x. I'm going to pull that out. The second set should also have a GCF. This one has a GCF of 3. I'm going to pull that out. So this is what it looks like. If I'm doing this AC method correctly, whatever's left behind after I pull out the GCF should always match up. In this case, I get an x plus 4. That's the new GCF. Factor that thing out, and what's left behind is 2x plus 3. So now I have just factored the trinomial 2x squared plus 11x plus 12. Okay? That's the method called the AC method. So this is not on your flowchart like how to do it. It just says to do it. So you might flip your flowchart over and write some steps down here. So we're assuming that our leading coefficient is not 1 and ax squared plus bx plus c, and that a is not a perfect square, so it's not a perfect square trinomial. Okay, so step number 1 is you're going to find the product a times c. Alright, so that's our product. We're looking for two factors that multiply up to that number. Okay, step number 2 is you're going to find p and q such that they multiply up to that ac, the product you just found, and they're going to add up to the middle term of b. Okay, once I have found those two terms, I do not put them in the parentheses. I am going to expand the middle term with them. Instead of having the bx term, I'm going to use the two factors that I just found, the p and the q, to expand it. Ax squared plus px plus qx plus c. Then I'm going to group up the first set, group up the second set, and finish out by factoring by grouping. Okay? So this is a nice application of factoring by grouping. And we can do that. That part's easy. So let's give it a try, shall we? So the first one, we got 6x squared plus 5x plus 1. AC method says that my product has to be 6 times 1, which is 6, and it has to add up to 5. So what times what gives me 6 and adds up to 5? How about a 3 and a 2? Okay, so those are the ones that I'm going to use to expand out the 5x. So I'm going to rewrite this as 6x squared plus 3x plus 2x plus 1. And it makes no difference which one of those came first. Okay, so we could have put the 2x before the 3x. It wouldn't matter. You would still get the same factors at the end. Okay, so let's group up the first set. Let's group up the second set. The first set has a common factor of 3x. So I'm going to pull it out. 3x. What's left behind is a 2x plus 1. Okay, if I look at the second set, it says 2x plus 1. It doesn't have a common factor. So if it doesn't have a common factor, always pull out plus 1. Always pull out plus 1. 2x plus 1. Because really, they do have a factor of 1. It doesn't seem like it's helpful, but it will be whenever you go to write your final answer. Because they have a common factor of 2x plus 1, factored out. And then whenever you divide both of those by 2x plus 1, what's left behind is 3x plus 1. If you didn't pull out the plus 1 before, you might be confused. What am I supposed to put down for the second one? 3x plus 1. So there is the factors for number 1. Okay. Number 2. N squared plus 4n minus 8. Now I might go, hey, well 4n squared, that's a perfect square. Well, if this is a perfect square trinomial, then 8 has to be a perfect square too, but it's not. So let's use the AC method. Hey, wait. Before I use the AC method, look at this. Look at 4, 4, and 8. Those have a common factor. They have a common factor of 4. Let's pull that thing out first. 4 times n squared plus n minus 2. There we go. Hey, and now I don't even have to use the AC method on it. I'm looking for a product of -2 and a sum of 1. So 2 is prime. The only factors could be 1 and 2. And if I subtract those, I would get 1. I know it's going to subtract because I have a negative product, which means that this is going to be 4 times. And the first set of parentheses, let's do n. It's going to be plus 2 because the middle term is positive, and n minus 1. There we go. See, here would be a case where if I didn't factor out the 4, the GCF, then I would have had to use the AC method, which we know is a little bit more complicated than not having to use it. All right. Finally, number 3 here, 5m squared, definitely not a perfect square, minus 9m minus 2. So our product, 5 times -2 is -10, and our sum is a -9. Okay, so the two things, how about 10 and 9? Let's go with a 10 and a 9, because if they, 10 and a 9, that's silly, 10 and a 1. Gonna multiply up to 10. Okay, there we go. Because if they get subtracted, then I'm going to get a 9 from that. Okay. All right, and I also know that the 10 is the one that's going to be negative, and the 1's going to be positive because it has to add up to a -9. So let's use that to expand the middle term. Now, when I do this, even though earlier I said it doesn't matter which one comes first, If one of them's negative and one of them's positive, always write the negative one down first. If both of them are negative, you don't have a choice. But if one of them is positive, write the negative one down first. I'll show you why in just a second. So 5m squared minus 10m plus m, 1m, right, minus 2. So the reason why I would want to write that negative one down first, so that whenever I group it, I don't chop off the negative sign for the second term. Okay, so now factoring this by grouping, I can pull out a 5m from the first one, and it's going to be m minus 2. And look, m minus 2 is what's in the second set of parentheses. So what is it that I'm going to pull out? That's right, plus 1. So m minus 2. So we have a common factor of n minus 2. We pull that out, and what's left behind is 5m plus 1. And I've just factored that one by the AC method. There we go. So here are your last set of problems here to practice before we do it for real in the classroom. Okay? Real life classroom application of factoring. Alright, anyway, so pause the video, do those 4 factoring problems, perhaps using the AC method.